Hello, this is Sujit. Welcome to Physics 2020. So today in this section we are going to discuss the resultant or addition or combination of vectors. So in the previous section we have discussed about the introduction of vectors and scalars. What is vector, what is scalar, what is the difference between vector and scalar, what are the properties of vectors and scalars. Okay, so what are the types of vector, what are the properties of vectors, what is the angle between two vectors, what is the parallel shift of vectors. So these are the things we have discussed in the previous section. So in this section we are going to discuss the combination of vectors or resultant of two vectors. Actually this is a very important topic in physics. When and wherever we are dealing with vector quantities, okay, vector quantities, this concept will follow you. Also that is Neet and Jeemains section. This topic plays a vital role. You can expect a variety of questions from this topic, or otherwise we can solve the problems. We have to solve the problems by applying this concept. Okay, by applying this concept. So let's start. That is addition or combination or resultant. Okay, resultant of vectors. Resultant of vectors. Okay, suppose m1 is equal to, that is 5 kilogram. Okay, m2 is equal to 10 kilogram. Okay, 10 kilogram. So what is m1 plus m2? That is, we can write, definitely we can write that is 15 kilogram, because mass is the scalar quantity. Okay, scalar quantity. So ordinary rules of algebra can be applied for scalar addition. Okay, suppose this is a vector. Okay, vector, that is f1 vector is equal to 5 Newton. Okay, 5 Newton. f2 vector is equal to 10 Newton. What is f1 vector plus f2 vector? So shall we write that is 15 Newton? No, because it is a vector quantity. So the vectors have both magnitude and direction. So the ordinary rules of algebra cannot be applied for vector addition. Okay, so for vector addition we are using special rules for vector addition. Okay, special addition. So what is resultant of vectors? So resultant of vector is nothing but it is a single vector. Okay, single vector which has both magnitude and direction. It would produce the combined effect of the individual vectors together would produce. Okay, so what is resultant of vector means? Resultant of vector is a single vector which has both magnitude and direction, which would produce the combined effect of the individual vectors together would produce. So that is the definition of that is resultant of vectors. So the process of finding the resultant of vector is called combination of vectors. The process of finding the resultant vector, resultant of two or more vectors is called combination of vectors. Okay, combination of vectors. So since the vectors have both magnitude and direction, okay, magnitude and direction, so ordinary rules of algebra cannot be applied for vector addition. So the special rules of vector addition is applied. So one is that is triangle law of vector addition. Triangle law of vector addition. And two, parallelogram law of vector addition. So these are the two laws we are using for finding the resultant of vectors. Okay, triangle law of vector addition or parallelogram law of vector addition. Okay. So what is triangle law of vector addition? We will see one by one. First, that is triangle law of vector addition. Triangle law of vector addition. What is triangle law of vector addition? So if two vectors both in magnitude and direction are represented by the two adjacent sides of a triangle. Okay, two adjacent sides of a triangle taken in the same order. Then the third side represents the resultant of these two vectors which have both magnitude and direction taken in the reverse order. Okay, so that is the statement of triangle of vectors. That is, if two vectors which have both magnitude and direction are represented by the two adjacent sides of a triangle taken in the same order, then the third side of the triangle give the resultant of these two vectors. Resultant of these two vectors which have both magnitude and direction taken in the reverse order. So that is the triangle of vectors. If this is a vector, okay, so O P and another vector, that is PQ, okay, PQ, then the third side, okay, third side. So according to, that is R is equal to this is A vector and this is B vector. So R vector is equal to A vector plus B vector. So suppose two vectors, that is A vector and B vector, are represented by the two adjacent sides of a triangle taken in the same order. Okay, taken in the same order. Same order means from the head of this vector another vector starts. Okay, so this is the same order. So then the third side of the triangle will give the resultant of these two vectors, or combination of these two vectors, or addition of these two vectors. That is, according to triangle of addition, this side taken in the reverse order will give the resultant of these two vectors, or addition of these two vectors. So we can write R vector is equal to A vector plus B vector. Okay, B vector. So this is triangle law of vector addition. Then the next is analytical method of triangle law. Okay, analytical method of triangle law. Suppose two vectors A and B which are inclined at an angle theta. Okay, suppose two vectors A and B which are inclined at an angle theta. So find the resultant, find the magnitude of the resultant and the direction of the resultant of these two vectors using triangle law of addition. Okay, triangle law of addition. So A and B are two vectors which are inclined at an angle theta. So we have to find the magnitude of the resultant of these two vectors as well as the direction of the resultant of these vectors using triangle law of addition. So what the triangle law of addition says, that if two vectors both in magnitude and direction are represented by the two adjacent sides of a triangle taken in the same order, then the third side third side will give the resultant of these two vectors in both magnitude and direction taken in the reverse order. So according to that statement, so this is A vector, so this is the point O, okay, so P, so that is A, okay, A vector A, and triangle law, okay, so this is B vector, okay, B vector, that is Q. Then according to the triangle law of addition, the third side, okay, third side R vector is equal to A vector plus B vector. So the third side, if two vectors taken in the two adjacent sides of a triangle taken in the order, same order, then the third side, which is in the opposite direction, give the resultant of these two vectors. Okay, so draw Qn, okay, draw Qn perpendicular to OP produced, okay, OP produced. So this angle is 90 degree, okay, this angle is 90 degree. So according to the parallel shift of vectors, these two vectors are inclined at an angle theta. So according to the parallel shift of vectors, this angle is theta, okay, this angle is theta. So this angle, so this is the direction of the resultant, okay, direction of the resultant from A vector. I am taking this angle is beta, okay, beta. So from the diagram what we can write, that is angle QPN is equal to theta, OP is equal to A, then PQ is equal to B, okay, then OQ is equal to R, okay. From the diagram we can write triangle QPN is equal to theta, OP is equal to A, PQ is equal to B, that is the magnitude, and OQ is equal to R, okay, R. So from the right angled triangle Q right angled triangle QPN, okay, QPN. So sin theta is equal to opposite side by hypotenuse, that is Qn by, that is hypotenuse, that is PQ. So that symbolize Qn is equal to PQ sin theta, that symbolize, what is PQ, that is B, that is B sin theta, okay. So I am considering the right angular triangle, that is QPN, okay, QPN. So sin theta is equal to Qn by PQ. So Qn is equal to PQ sin theta. What is PQ? That is equal to B. So cos theta is equal to adjacent side, that is Pn, by hypotenuse, that is PQ. So that is Pn is equal to PQ cos theta. So that symbolize, what is PQ, that is B cos theta. So from the right angle triangle ONQ, right angle triangle ONQ, okay, ONQ. So this right angle triangle, so OQ square is equal to ON square plus on square plus qn square. Okay, n square plus qn square. So that's equal to, what is on? On, this is on, so we can write on is equal to op plus pn, op plus pn square plus, what is qn? That is b sin theta. Okay, b sin theta square. So that's equal to, what is op? op is equal to a plus, what is pn? That is b cos theta, b cos theta square plus b sin theta square. Okay, b sin theta square. So this is equal to a plus b the whole square, that is a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Okay, sin square theta. So that we can write, that is a square plus, take b square commonly outside, from these two terms take b square commonly outside. So b square cos square theta plus sin square theta plus 2ab cos theta. What is cos square theta plus sin square theta? That is 1. So that's equal to a square plus b square plus 2ab cos theta. This is oq square. Oq square is nothing but, that is r square. Okay, r square. Therefore r is equal to square root of a square plus b square plus 2ab cos theta. Okay, so this is the resultant of, this is the magnitude of the resultant of these two vectors, a vector and b vector. So suppose two vectors a and b are inclined at an angle theta. So what is the magnitude of the resultant of these vectors? Means it will give, that is r is equal to a square, that is the square first vector, second vector 2 times ab, then the theta cos theta, that is cos theta means theta is the angle of inclination of these two vectors. Clear? Next we have to find, this is the magnitude of the resultant, we have to find the direction of the resultant also. Okay, direction of the resultant. Okay, direction of the resultant. So I am again considering the right angle triangle ONQ. Okay, considering the right angle triangle ONQ. Okay, from this I am writing, that is tan beta. Okay, tan theta is equal to, tan beta is equal to opposite side, that is qn, by adjacent side, that is on. So that implies qn, what is qn? That is b sin theta, what is on? That is op plus pn. So that's equal to b sin theta, what is op? That is a plus, what is pn? That is b cos theta. So that's equal to, okay, that is tan beta. Okay, b sin theta divided by a plus b cos theta. So we have to find beta, that is beta is the so beta is the angle of separation of the resultant of vectors. So we have to find the direction of resultant, means the direction of the resultant from this vector, a vector. Okay, so we have to find beta. So beta is equal to tan inverse of b sin theta divided by a plus b cos theta. Okay, a plus b cos theta. So this gives the direction of the resultant vector. Direction of the resultant vector. Direction of the resultant vector in the sense the direction of the resultant from A vector. Okay. So beta is the angle of the resultant from this vector A. Okay. So that gives the direction of the resultant vector. Okay. So if two vectors are inclined at an angle theta, so what is the magnitude of the resultant? So that is R is equal to square root of A square plus B square plus 2AB cos theta. So this gives the this expression gives the that is magnitude of the resultant, and this expression gives the expression gives the magnitude of the resultant, and this will give the that is direction of the resultant vector. Clear? So next is Parallelogram Law of Vectors. Parallelogram Law of Vectors. Okay. So if two vectors both in magnitude and direction are represented by the two adjacent sides of a parallelogram drawn from a common point. Okay, drawn from a common point. Then the diagonal represents the resultant of these two vectors drawn from the same point. That is called Parallelogram Law of Vectors. So Parallelogram Law of Vectors states that if two vectors both in magnitude and direction are represented by the two adjacent sides of a parallelogram drawn from a common point, then the resultant will give, that is, then the diagonal will give the resultant of these two vectors both in magnitude and direction drawn from the same point. Okay. So if so this is a parallelogram. Okay, parallelogram. So parallelograms. So this is A vector, two adjacent sides of a parallelogram. Then the diagonal, this is the diagonal of the parallelogram. So this diagonal gives the resultant of this vector, that is A vector plus B vector. So this is the Parallelogram Law of Vectors. If two vectors both in magnitude and direction are represented by the two adjacent sides of a parallelogram, drawn from the common point, then the diagonal drawn from the same point will give the resultant of these two vectors. Okay, this is called the Parallelogram Law of Vectors. Then analytical method of Parallelogram Law of Vectors. Suppose two vectors, okay, two vectors, A vector and B vector. So this is A vector and this is B vector, which are inclined at an angle theta. Okay, theta. So we have to find the resultant of these two vectors using Parallelogram Law of Addition. Okay, Parallelogram Law of Addition. So what is the Parallelogram Law of Addition? That is O, it is P, okay, OP. Okay, so two vectors OP, this is OQ, and this is S. Okay, so this is A vector and this is B vector. If two vectors both in magnitude and direction are represented by the two adjacent sides of a parallelogram drawn from a common point, then the diagonal which is starting from the same point, okay, starting from the same point will give the resultant of these two vectors, that is r vector is equal to a vector plus b vector, okay, b vector. So draw Sn perpendicular to OP produced, okay, draw Sn perpendicular, this is n, perpendicular to OP produced. So what is this angle? This angle is 90 degree. Okay, so the two vectors are inclined at an angle theta. So this is theta. Okay, this is theta, and this angle. So the direction of the resultant. Okay, direction of the resultant from the A vector I am taking, that is beta. Okay, beta. So this angle is two vector, that is theta. So definitely this angle is also theta. Okay, theta. So from the diagram we can write that is QOP, angle QOP, okay, is equal to angle SPN is equal to theta. OP is equal to A, OQ is equal to B, that is OQ is equal to, this is OQ, and the PS, okay, PS is equal to B, OS equal to R, okay, OS equal to R. So from the diagram we are writing that is angle QOP and SPN is equal to theta. OP is equal to A, OQ is equal to PS equal to, that is B, okay, PS equal to B, then OS equal to, that is R, okay, OS equal to R. So first I am considering the right angle triangle from right angle triangle, that is SPN, okay, SPN, okay. So from this, sin theta is equal to opposite side by hypotenuse, that is PS, okay, PS. So that implies Sn is equal to PS sin theta, okay, PS sin theta. What is PS? That is B. So that implies B sin theta, okay, B sin theta, okay. Next, cos theta is equal to adjacent side, that is Pn by hypotenuse, that is PS, that's equal to Pn is equal to PS cos theta, that is, what is PS? That is B cos theta, okay. Next I am considering the right angle triangle OSN, okay, right angle triangle from right angle triangle OSN, okay, OSN, okay, I am right, that is OS square according to Pythagoras theorem, okay, Pythagoras theorem, OS square is equal to ON square plus Sn square. What is ON? That is OP plus Pn square plus Sn square. What is OP? That is A plus what is Pn? Pn, that is B cos theta square, B cos theta square plus Sn, that is b sin theta square. So that's equal to a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Okay, that's equal to a square plus, take b square commonly outside from these two terms, so b square cos square theta plus sin square theta plus 2ab cos theta. So that's equal to a square plus b square cos square theta plus sin square theta 1, that is 2ab cos theta. So this is OS square. OS square is nothing but, that is R square. R square is equal to a square plus b square plus 2ab cos theta. So we have to find R, that is the resultant, magnitude of the resultant, that is square root of a square plus b square 2ab cos theta. 2ab cos theta. So this gives the resultant of these two vectors, a vector and b vector. If two vectors are inclined at an angle theta, so if you find the magnitude of these two vectors, so we will get, that is R is equal to square root of a square plus b square plus 2ab cos theta. Okay. Next, we have to find the direction of the resultant. Direction of the resultant. So direction of the resultant. Okay. So the direction of the resultant, it makes an angle beta from the a vector. So that angle we have to find. That gives the direction of the resultant. Okay, resultant. So from, I am considering the triangle that is OSN. Okay, OSN. So tan beta is equal to opposite side Sn by hypotenuse, that is On. So that's equal to Sn by, what is On, that is OP plus Pn. So Sn, what is Sn? So Sn, that is b sin theta. What is OP? That is a plus, what is Pn? That is b cos theta. This is tan beta. So we have to find beta. Beta is equal to tan inverse of b sin theta divided by a plus b cos theta. So this gives the direction of the resultant vector. Direction of the resultant vector with a vector. So if two vectors are inclined at an angle theta, so what is the magnitude of the resultant? That is equal to square root of a square plus b square plus 2ab cos theta. So this gives the magnitude of the resultant, and what is the direction of the resultant means beta is equal to tan inverse of b sin theta divided by a plus b cos theta. So everything you know, that is b is the second vector. So sine of the angle of inclination, a plus b into, that is cos of angle of inclination, gives the direction of the resultant vector according to parallelogram law of vectors. Okay, parallelogram law of vectors. This gives the resultant of the magnitude and this gives the direction of the resultant. Okay. So the next is the resultant of vectors or combination of vectors either by triangle of addition or parallelogram law of addition. So the resultant of the vector is, the magnitude of the resultant is r is equal to square root of a square plus b square plus 2ab cos theta. Then direction of the resultant is, that is b sin theta. So beta is equal to tan inverse of, okay, tan inverse of b sin theta divided by a plus b cos theta. Am I right? So the properties of vector addition, properties of vector addition, properties of vector addition. So first point, so vector addition is commutative. Vector addition is commutative, that is a plus b is equal to b plus a. So these two are equal, a plus b is equal to b plus a, that is called a commutative law. So the second point, vector addition is associative. Associative, that is a vector plus b vector, okay, a vector plus b vector plus c vector is equal to, so a plus b plus c. Okay, this is called associative. So commutative means a vector plus b vector is equal to b vector plus a vector. These two are same. Okay, then associative means a plus b plus c, that's equal to a plus b plus c. So that's why if you check the values of these two, that is you will get the same value. So we can write it is associative. Okay, associative. Then we have to explain some more special cases of vector addition. Okay, special cases of vector addition. So special cases. Special cases. First point, if two vectors are acting in the same direction, okay, same direction. If two vectors are acting in the same direction, that is theta is equal to 0. Theta is equal to 0. The angle of inclination between the two vectors is equal to 0. So therefore, r is equal to square root of a square plus b square plus 2ab cos 0. Cos 0 means 1. Okay, 2ab cos theta, that is cos 0, that is 1. So this is nothing but that's equal to square root of a square plus b square plus 2ab, that is a plus b the whole square. So that's equal to a plus b. So if two vectors are acting in the same direction, that is the angle of inclination between the two vectors is 0. So we will directly write that is the resultant of vector is r is equal to a plus b. So what about the direction of the resultant, that is theta is equal to 0. So therefore beta is equal to sin 0 0. So beta is equal to 0. Beta is equal to 0. So what is the conclusion, that is the resultant acts in the direction of the two vectors. Okay, the resultant acts in the direction of the two vectors. Okay. So beta is equal to 0. Then second case, case 2. If the two vectors are acting in the opposite direction, okay, opposite direction. To opposite direction. That is theta is equal to 180 degree. Theta is equal to 180 degree. 180 degree. So one vector is acting in this direction A and another vector is acting in this direction B. So A and B. So the angle of inclination between the two vectors is 180 degree. So what about the resultant? So A square plus B square plus 2AB. Okay, 2AB cos 180, that is minus 1. Okay, cos 80 minus 1. So a square plus b square minus 2ab. So nothing but it is a minus b the whole square. So that's equal to a minus b. Okay, a minus b. Okay, a minus b. So this is the resultant. That is, we can write that is a plus minus b. Okay, a plus minus b. So this vector is acting in this direction, so that is positive a. This vector is acting in the opposite direction, that is minus b. A plus minus b. So so what about the direction of the resultant? So beta is equal to tan inverse of sin 180. Sin 180 is also 0. So therefore beta is equal to 0. Beta is equal to 0. So the resultant, whether the resultant is in the direction of A or B. So in the first case, that is the two vectors are acting in the same direction. Okay, two vectors are acting in the same direction. That is A and this is B. So the resultant is acting along A or B in the first case. So here if the two vectors, that is A vector is acting in this direction and B vector is acting in this direction. So the beta is equal to 0. That is the angle of inclination, angle of the resultant is 0. The direction of the resultant is 0. So the question is whether the resultant is in the direction of A or B. So if the resultant is that is the angle of inclination of the resultant is 0, but whether it is in the direction of A vector or B vector. If r is equal to this r, that is the magnitude is equal to positive. Okay, magnitude is equal to positive. It is in the direction of A vector. The resultant is in the direction of A vector. Okay, if the resultant of the magnitude of the resultant is negative, negative, it is in the direction of B vector. So the angle of inclination of the resultant is 0. Okay, resultant is 0. So the resultant will act in this direction of A or B. The next question is whether the resultant will act in the direction of A vector or B vector. That is a question. So if the resultant is positive, the magnitude of the resultant is positive, it is acting along A vector. If the resultant is acting in the if the magnitude of the resultant is negative, it is acting in the direction of B vector. Okay. So the next is third case, that is if the two vectors are inclined at an angle 90 degree. That is the third case. Two vectors are acting, that is the third case. Two vectors are at 90 degree. Okay, 90 degree. So what about the resultant? R is equal to square root of A square plus B square plus 2AB. Cos 90. So cos 90 is 0. Okay, cos 90 0. 2AB cos theta. So this term becomes 0. So therefore R is equal to square root of A square plus B square. So this gives the resultant. So what about the direction of the resultant? So beta is equal to tan inverse of, B sin theta, sin 91, that is B by A plus B cos theta, that is cos 90, that is 0. So B by A. So this gives the resultant of the direction of the resultant. Clear? So these are the special cases of vector addition. So in this section we have discussed what is resultant of two vectors or combination of two vectors. So the normal ordinary algebra rules cannot be applied for vector addition. So special laws of vector addition we are using, that is triangle law of vector addition and parallelogram law of vector addition. So using triangle law of vector addition and parallelogram law of vector addition, so we have derived the formula for the magnitude of the resultant, direction of the resultant, and we have discussed the special cases also. So with this I wind up this session. So in the next section we will discuss the problems of that is combination of vectors using this formula. Okay, since then, thank you.